Ho ho ho! What's going on, guys? Nemesis Snow 5 here, coming at you with a Christmas cracker. On this joyous winter day, I've decided to bring you a festive surprise. That's right, it's a new NP5 series. And what we're going to be doing is playing maths, because what's more festive than a bit of mathematics? I bet Santa Claus himself, I bet he does mathematics all the time. I mean, what else is he doing the other 365 days of the year? Or should I say 366 minus 1 equals 365 days of the year? You know? That's just one of the many maths problems Santa would encounter in his day-to-day exploits, canonically. Anyways, we're gonna be starting at one of these. Which one exactly? I'm thinking first year, because it's my first year of doing this, since this is a brand new project that I'm taking on. So this is, as it says here, here's a list of all the math skills students learn in first year. And if there's one thing I know about first year, it's the infamous year where they added letters to maths. The dreaded day when they wrote up X on the board, and you were like, what? That's not a number, that's X. So, and you know what they always do? You know what they always do in maths? They're always like, find X. Where is X exactly? Well, I'll tell you, it's right here. Transformations and congruence, whatever that means. So, without further ado, we're going to be hopping into X1, symmetry. What better way to start a Christmas video than with a symmetric snowflake? I'm gonna go yes for this one. Okay. Is this shell symmetric? No. There are two different worlds going on here. Okay. Is this boat symmetric? Yes, with the crossed oars. Okay. Is this plane symmetric? No, the front is different to the back. I'm smart. This flower? No, that's a terrible cut. You didn't even get through the middle of the stem. Come on now. Okay. Is this gem symmetric? Yes. Is this flower symmetric? Yes. Is this blade symmetric? No. Is the leaf symmetric? You think it would be, but no, because the line is vertical. If it was horizontal, it would be symmetric. They try to catch you out like that. Is that trophy symmetric? That's my reward for getting the leaf. Okay, and there we go. We did it. We did one. X2. Identify reflections, rotations, and translations. Okay, which one shows reflections? So you gotta imagine the mirror. Okay, you gotta imagine there's a mirror in the zone on the plane being shown, and I can see clearly now. This little shape looks in the mirror and sees A. Correct. Okay, a rotation. So now I gotta imagine myself like rotating the shape. Well, I gotta think back to all the times I've like rotated things, like Christmas decorations, for example. So I think it's this one. Yes. Okay. Which one shows a rotation? I clicked the reflection. I clicked the reflection like the sheep I am. My bad. Okay, a rotation. Rotation, not a reflection. I think it's C. I think it's C based on vibes. Okay. Which one shows the translation? Well, none of these are in like Spanish or whatever. So like, how am I meant to know? Does this just mean like moving it? It does. Okay. Today I learned. Okay. A reflection. Again, look in the mirror. What do you see? I don't see any of these. What? How does that work? Oh, see, I was thinking east to west, but no, it is. It's south to north technically, although A is still in the same place. So, I don't know what's going on there. Okay, reflection. A, easy. Okay. L, which shows a reflection. Huh. Which one does show a reflection? I'm actually stuck. This isn't a bit. What is this? How do you like... Because it's like it's a J if you flip it west to east. But like north, it's like an R. I don't see any R. I see reverse R. Is that it? Is that meant to be it? Or no. Okay, hear me out. It's like a diagonal reflection, which is what you see in C. Yes, okay, I figured it out. Translation, you literally just look for the same shape, but in Spanish. Which one shows the rotation? C. I know I've rotated so many Tetris blocks. There we go. Wow, great. Translations graph the image. Okay, so apparently you gotta click where the point goes after it's translated to Spanish. Okay, it's down here. Perfect. What do you mean? What do you mean it's there? Left. I just assumed it was down. Naturally. Okay, 2 left. There we go. Redemption. Alright. So instead of wait, okay, 9, okay, negative 9 plus 7 is negative 2. Okay, gotta start using the numbers here. 8 minus 8 would be 0. Perfect. 9, no, wait. Oh man, okay. 9 plus 1, yeah, I'm right. I gotta keep in mind which of the numbers I'm using as well. It's very complicated, you know, we're thinking in 2 dimensions here. You know, it'd be crazy if they added a third, though. 3 to the right. That's 2. 8 up. There we go. I'm right. Shut up. 2 units down. Yep. 1 unit left. Yep. 4 units left and 8 units down? Oh, man. Okay. I don't know about that one. 10 is 2. Yes. There we go. That's our bit of translation. Psych, apparently it's not. We're doing X4 translations. Find the coordinates. We're still on translations. We're still on Spanish. We gotta actually use the numbers now, which is annoying. Don't mind this on-screen keyboard. This is a gift from Santa. Anyway, 2 units down. So that'll be minus 6 and minus 2, right? No, 2 units down. 6 again. Cool. H is 8 units down. Oh, the minus 1, 2. Can't even move. Wonderful. 4 units up. So that'll be what? Minus 1. Minus 2. 4, 2 is 2 units left. 2, 2. Nice simple one. 1 unit up. That's got to be 1, negative 2. 3 units up. Minus 5 and 0. Great. 1 unit left and 4 down. Negative 5. 2. That's not 2, that's minus 2. It's minus 1 and minus 3. 3 units left. Oh, minus 3 and then still, sorry, 2. 3 units down would be minus 6 and minus 1. Brilliant. That's it. That should be it. X5 reflections graph the image. Oh man, I do plenty of reflections, I can tell you that. I'm an expert at this. Oh, of course. Yeah, I just assumed it was the other one. Great, cool. The y-axis, over the y-axis. That's the vertical one. I know this. Where are you? There you are. Hiding under the arrow. Over the x-axis. It's gotta be here. Over the x-axis. There's a square. There's a square. Come on. Come on. You can't make me do the square. You gotta like... Oh man, I gotta draw a whole square. What is this, man? We've come so far since junior infants. Back then we were just like picking squares. Now we're making them. Didn't even work because I did it diagonally for some reason. That's so cool. Great job. Wow, I'm mentally stable right now. Yeah, rectangle. Sure, man, whatever. Just there we go. Incorrect because it's the wrong one. This isn't a bit. Okay, this one's just a point, so I should be cool. It's just the x-axis. Are you kidding me? Are you joking? Okay. The y-axis. Now this is where we come back. Okay, this is where we come back. Wait, I nearly did the wrong one. You. Okay. Do I just get limited now? Is that what happens? You just get limited from like, okay, over the x-axis. How many is that? Like 6? Okay, we got one right. And they've given me a triangle to do. Okay, so it's over the x-axis. So it's at 4, and then 10, all the way up in 10. We got here. The last one's also in 10. So it's like here. Did we get it? We got the triangle. Okay. Oh, what is this? Reflecting over a line? How? How do you do that? There we go. Okay. We've redeemed ourselves, I think. I'm starting to see a pattern here. X6's reflections find the coordinates. So, as usual, doing draw the shape and then type in the numbers. So, we're going to be bringing up the Christmas gift again. All right. Reflected. So, you just negative them, right? No. Okay, you negative one of them. It's not diagonal. Are you kidding me? Of course. You make the y value negative when it's over the x-axis. Okay, that's pretty clever. That's smart. Whoever came up with that was a smart person. Okay, over the x-axis. So again, it's a 2, 6. Nice, we got the hang of it. Over this line. So it'd be, what changes? The x-axis. So it's -5 and still -3. Great. Okay. So it goes from 2 all the way to -6. It's quite the jump. Ooh, diagonal line. Okay. So it just changes by 1, right? So 1 down, 1 to the left. So they're both negative. There we go. Perfect. And then this one is the same thing, except the y-axis changes positive because it's going up. I'm so proud of myself. Okay. This one. It's changed 3 times, I think. And they're both negative. Perfect. Okay. Is this... You just swap them? You swap them over? Perfect. Okay. We got ourselves a medal. Been a while since I've seen one of those. Okay, so this is a whole triangle that we're moving now. 0, -5. Gotta be... Okay, wait. T and S are the same. It's U that changes. Got it. I'm figuring things out. Okay. So it would still be -4, but instead of -10, it's +10. Yes, we got ourselves a triangle and a medal and a 75 smart score out of 100. You already know it, you already love it. X7 is rotations, graph the image, our favorite Christmas activity. Okay. You rotate 180 around the origin. So that is, yeah, this is kind of like a reflection if you think about it. Okay, 270. So that's Okay, so what's that? 9-3. So it'd be like 9 isn't, no, that wouldn't work. It'd be 9, it'd be -9. 3. Okay. Oh, it's a, yeah. It said clockwise. It said clockwise, and I just, I assumed it wouldn't be that. I'm starting to see a pattern here. Okay. That correct? Yes. 90-degree clockwise around the origin. Perfect. Yes. Okay, 10, 10. This one's pretty chill. Clockwise again. Okay. Anti-clockwise. This one's also pretty chill. Good work. 180. Again, bit of a return to reflection, a bit of an R to R, if you will. 90-degree clockwise. It's gonna be what? Okay, it's 4 away from the line, and it's 7 away from the other line. Great. -8, -10, and you rotate it anti-clockwise. I always picture the clock in my head when I'm figuring out which is clockwise and which is anti-clockwise. That mental image never fails me. Okay. Where would it go? That's crazy. It's like, it's at the edge, kinda. Yes, okay. 270 degrees clockwise. So that brings us back here. Is where I think it brings us. And I was wrong. What did I click? Where is it? It's there. Ah, wrong. Yeah. Got it off by like 1. Well, that's one way to end it. Here we are at the final bit of the pattern. Okay. What are the coordinates of the rotated one? Right, again, this is the same reflection one. I gotta whip out the gift. So it's 1 and -5. Yes, okay. 180 again. So you just swap the signs and you're done. 270. Okay, now you gotta think. How do you even do that? What's the formula for this? 270 anti-clockwise. So that's 90 clockwise. And that brings us to so it's 6, it's -6 and 4. Oh, I'm starting to see a pattern here. I'm starting to see a formula here. Okay, 270 clockwise. So you bring it back down. So -4, it's you swap them. You swap them, right? Right? No. They're both negative. And it's the y is still yeah, so really you're okay. You don't even listen to me. Don't even listen to like anything I say. 90 degrees anti-clockwise, sure, go ahead. That's what, like the same as a reflection over the x-axis, is it not? So you change the y value, but x remains the same. Okay. I'm seeing connections. I'm seeing things come together in my mind. We might be able to come back from this. Okay, 90 degrees clockwise. So that'll be, you just flip. You flip. That's literally it. It's all connected. That's crazy. Who came up with this? Okay. Super. Swap the signs for 180. That's the classic rule. That's right. They're just giving me points. They're just handing them to me now. 270 clockwise. So that's 90 counterclockwise. As the is that an American English thing? Do the Americans say counterclockwise? Am I being culturally assimilated into the Imperium? 5 and 3, I think. No, it's 3 and 5, of course. Okay, good. We still got another. 270 anti-clockwise is 90 clockwise, so that brings us up to an x-axis reflection, meaning that this is the same and this is different. What's the point? I don't think my formula is working. What's the point anymore? Something newer this time. Lines, line segments, and half lines. So this one just tells you, this one just teaches you symbols for lines. And I may have forgotten a lot as shown in the past few little sections, but wait, this is W. This is an X. You know what? We're doing this. We're doing W9 now. This is a line. This is a half line. This is a line segment. This is a half line. This is a line. That's a segment. That's a half line. That's a line. What's the name of this figure? Can I call it like John? What's the name of this figure? Oh, is it half line? Oh wait, okay, ZY, I think. What? There's a square bracket in there? I've never been taught this in my life. What? That's crazy. They use square brackets for this? Back in my day, it was just for like multiple layers of brackets. What is this nonsense, man? What is it? It's called okay, it's high but with no boundaries because there's two things. Okay, that's my hypothesis. Great. See, now I feel good about myself. X10, or as I like to call it, XX. Side lengths and angle measures of congruent figures. So what you got to do is you look at this detail triangle and you see it's the same shape as this this measly undetailed triangle, and you take the info and you apply it to the one without info. I think really this should be called translation. This is kind of like translation, you know, seeing concepts in one triangle or language and, you know, bringing it over to another and being like, okay, these are equivalent. That's task manager. This is the keyboard. Okay. They're congruent. What is the angle of H? So H gives me the vibe of the big angle. It does. Okay. What is J? Well, J is the small one, so 37. What is K? It's kilometers. It's a big triangle. What is the W? Oh no, you gotta like think about this. So there's 180 degrees. 100 minus 65 is 35. Of course, I didn't even need to do that. It's in the other thing. What is W? It's gotta be 65, I think. Okay, based on vibes. V is 55. O is 37. S gotta be 34. VW gotta be 50. Not Y, 50. What is F? 31. What is YV? This isn't a triangle. No one signed me up for this. There. And we're done. Who up making congruent statements? Me, because I'm doing X11. Complete the congruent statement. Oh, you gotta get which is the equivalent. Okay, so that'd be X V W. Very nice. C D E F. That'd be N O P M. Nopem. Select all that apply. Oh man, this is work. Okay. JI is ST. I is ET. J is S. GJ is not quite TQ. Don't! Whoa. Almost got me. RSQ. Same as UVW. I pressed Y. Ignore that. That didn't happen. EF is equal to, that's equal to VU. DE is the same as UV. No, it's not. FD is 28. VT is 28. F is right angle, and T is not a right angle. Great. HGF gotta be M and O. Almost typoed again. BCA, SQR, QRST. How am I meant to get this? Okay, wait. The angles, of course. Almost forgot those. KL. Yup. 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 OPQR. Oh man, these lines are a classic. These lines are a classic. Those little angle indicators, I haven't seen those in years. It's like seeing an old friend. I think this is it. Great. This one seems pretty chill. You're just copying over angles, which I mean, look at it, bro. That's 90. That's 90. That's also 90. That is a right angle. Ooh, division. Missing angle. 80. Hold on. Need the gift. 6. Multiplication. Oh, they turned it around. They rotated it to try and get me. I'm smarter than that. I think they can get me to a bit of rotation. 146. 1. Wait. Last one, X13. Let's do this. Similar figures in direct measurement. Wow, it's like it's expanding. It's getting bigger, and 4, 3, and I guess 3. Gotta get the gift out one last time. Here we go. This is think mirror. It's gonna be biblical. Never mind. I didn't think mirror. Okay, hold on. Find R. So multiply by 2. Find T. That's gotta be wait. Yeah, again, it's a difference in magnitude of 2. This is also different to 2. I don't know, this is, you know, well, they always end this with the anticlimactic one, man. At least the others were like a challenge, you know? Like, I was doing terribly, but it was a challenge. If I was awake right now, I'd be, you know, enjoying this process, but I'm not. And that's a problem. Whatever, you can have that one. Oh, it's a difference of 4 this time. That's crazy. 36 is the correct term, I think. Oh, that's it. Well, that's the module done. Well, what am I meant to do again? Whatever, man. You got December Fools. See you next time.